So like I said, we are going to be in 2.8 today, which is distance, midpoint, and circles. Hopefully you can slide that over so it's more center. So the first thing we're going to talk about is distance. Distance is usually denoted with a little d. And so the distance between 2 points, which we label x1, y1, and x2, y2, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Basically, we're taking the distance between those points, squaring them and adding them, and then square rooting them. Something to think about with these equations that I keep giving you throughout the semester is you're going to need to know these for the final exam. You are not given a cheat sheet. You're not given these on the exam. So when you work through the problems, like I do, it's best if you write them out. Write out those equations. It may seem redundant and you're like, oh, I keep writing them out. Yes, but the more you write them out, the more in your head they're going to be. And so then when it comes time for a test, or for the final rather, because all your tests are on the computer, but for the final exam, you will have that and you'll be like, oh yeah, I remember distance. Distance is a square root, and you'll be able to write it out there. So just a little word of caution and advice, I guess. So let's find the distance between the points -1 and 4 and the other point of 3, -2. So again, I wrote out my distance equation, which is x2 minus x1 and y2 minus y1. Again, it does not matter if I designate this as x2, x1, or this is x2, y2, or x1, y1. It doesn't matter as long as I'm consistent. I usually keep them in the order that they are. So that means that my x2 value would be 3 minus my x1 value, which is -1, quantity squared, plus y2, well, that was -2, minus my y1, which is 4, quantity squared. So here I have 3 plus 1 squared plus a -6 squared. So I have 4 squared plus 36, because 6 squared, or -6 squared is 36. I have 16 plus 36, which gives me the square root of 52. Now that's not totally reduced. So let's see what goes into 52? Well, 52 is the same thing as 4 times 13. So that can be 2 square roots of 13. If, this is a big if, but if on the assignment it asks for a decimal representation, that is the only time you want to give a decimal. In this case, it's 7.21. That's an if. If not, you leave it as 2 square roots of 13. Only if they ask you for a decimal do you ever give a decimal, okay? Whenever you're doing the homework and the quizzes, there's usually little green instructions next to the answer box that will tell you what form they want you to do it in. Sorry about that. I had to pause because the chalk dust got to me really bad and I had to go get a drink. So that is midpoint. Or excuse me, that is distance. Next is midpoint. So again, if you can't read this very well up on the board, remember you can always pull up my notes to go alongside the video so that you can view it better. Okay, so midpoint formula. The midpoint of a line segment with ending points x1, y1, and x2, y2 is x1 plus y, or excuse me, x1 plus x2 over 2 and y1 plus y2 over 2. So notice this is a midpoint, so it's given in an x, y point. Basically, you're just finding the middle of each, of the distance between your x's and the distance between your y's. So let's find the midpoint of a line segment. Through the points 1, -6, and 8, -4. Again, while you're learning, it's best to write out what the equation was so that you have a lot of practice. So in this case, I have my x1 was 1, my x2 was 8, all over 2. My y1 was negative 6, whoops, plus y2 is negative 4, all over 2. So that gives me 9 over 2, comma, negative 6 plus a negative 4 will give me a negative 10 over 2. That's not quite reduced, so I have 9 over 2, comma, negative 5. Did I do that wrong? Oh, excuse me. This is a negative 8. That's a plus a negative 8, which will give me 7 here. Sorry. I guess I don't really have to change it because we did all the math right based on what I wrote. But plug in the numbers, pump out your midpoint. Hopefully that's not too hard and doesn't cause too many issues. And again, remember, if I move too fast in the lecture videos, you can always pause them so that you can continue writing. And you can also always fast forward or rewind, whatever works you need to do. Okay, so we found distance, we found the midpoint. Now we're going to talk about circles. So a circle is a set of all points in a plane that are equidistant. That's a big word. Equidistant. Equa sounds like equals, and that's why. That's what it means. That are equally distant from a given point or a fixed point called the center. The radius is the fixed distance from the center to any point on the circle. Hopefully those are kind of logical things. A circle is a set of all of these points out here that are equidistant, or that are the same distance away from the fixed point in the middle called the center. The radius is that fixed distance. So this is a generic picture of a circle. There's our center. Here's our point xy, which lies on the circle. The radius is the distance between our point and the center. The center we usually indicate with an h, comma k instead of an xy, because all of the xy's are going to be the points that actually lie on our circle. So we use the indicator hk for the point that actually lies in the center. Okay. Sorry for the movement. Really far away, but I think it'll be okay because I wrote really big. And I'll move you closer for the next ones here in just a second. So just like with an equation or a polynomial, we're going to have a standard form for our circle. The standard form is x minus h quantity squared plus y minus k quantity squared equals r squared, with the center, like I said, at hk, and the radius of r. So this is just the standard form. Usually we see circles written in standard form, just because it's the most conducive to utilizing, to like doing the math with it. It's kind of like for lines, we did y equals mx plus b. That's kind of the nicest form to have it in, because it's the easiest way to use it after that. Oh, I'm sorry, I just covered that up with my thumb. So let's find the standard form of a circle that has a center 0, 0, excuse me, goodness gracious, and a radius of 2. So we have 0, 0 as our center. That's our HK. We know our radius is 2. So r equals 2. So all we're going to have to do then is plug that in to our standard form for our circle. So we have x minus 0 squared plus y minus 0 squared equals 2 squared. That gives me x squared plus y squared equals 4. That is the standard form of a circle with the center at 0, 0 with a radius of 2. So what does that look like? And I will warn you, most of my circles, if I draw them on a graph, are going to look a little wonky. So here's my graph. There's my center at 0, 0. And then it said I have a radius of 2. That means I go out 2 spots every direction, and then I have a circle. It's actually a better circle than usual. Most of the time mine look a little bit more like diamonds because I have to connect all those circles or those points. Okay, try another one. So now let's find the standard form of a circle with the center at -2, 3 with a radius of 4. So we have a center at -2, 3. That's my h, k. I have a radius of 4. And then my standard form for a circle is x minus h squared, y minus k squared equals r squared. So I plug in those values. So I have x minus my h, which is -2, so that's where you need to be careful. You don't just put -2 in there because you have to make sure you're going to distribute in that negative. Plus y minus my k is 3 equals 4 squared. X plus 2 squared plus y minus 3 squared equals 16. I can't reduce it down any further. So what does this look like? Well, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay. If you were asked to graph this, first thing we'd do is we'd plot our center, which was -2. Oh, I didn't graph this one. I was like, why does this look weird? Because I didn't graph it. Well, I don't have any erasers over here. That's okay. I can graph it, but I need a better graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So we start with our center, -2, up 3, right there. And then I have a radius of 4. So that means I need to go out, up, down, all the directions in 4. So I go 1, 2, 3, 4. Then I go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Notice I just go along my x's and my y's because that makes it the easiest. Theoretically, you can go any direction you want, but that's going to be the easiest way. There's more of my wonky circle. But here is a circle centered at -2, 3 with a radius of 4. Okay, let's move on. So all of those have told us where the center and the radius are. But what happens if we don't know that and we're just given the equation and we have to figure everything else out? Well, that's what we're going to do now. For this problem, it says find the center, the radius, the domain and the range of the circle, and then we're also going to graph it. And the only things we are given are our equation. Luckily, that's all we need in order to come up with all of that other stuff, which is really good. So I'm going to write the standard form of a circle again, one just for practice, but also to remind us, because it's in the standard form of a circle that we have a lot of information. Remember, our circle, the standard form tells us that the center is at the point HK, which is here and here. So based on our equation of a circle, what is our center? Well, we know our H is 2, and our K, well look, it says minus K, but this is a positive 4. So remember, that can be written as a minus 4. That means our K value would be a minus 4. So right there is our center. The radius, we have r squared equals 9, right? So if we square root and square root, we get r equals 3. Now, all throughout this semester, I've said if you square root, you're going to have pluses or minuses, because theoretically you could have minus 3 times minus 3 would give you 9. But when we're talking about a radius, that's a distance. We're not going to talk about a negative distance. There's no way to go from the center out to the circle with a negative distance. So we're only going to concentrate on the positive. Okay? So we found our center, check. We found our radius, check. We need to find the domain, the range, and the graph. If it asks you to find the domain and range, I really recommend you graphing it first, because it's a lot easier to find the domain and range after you've graphed your circle. So let's do the graph first. 1, 2, 3, 4, 5, 6, 7, 8. I just do a generic number. I don't have any reason for doing this many. So again, we start with our center. We found our center to be 2, negative 4, 2, 1, 2, 3, 4. Right here is our center. From that center, we have a radius of 3. So we need to go up 3, 1, 2, 3. We need to go to the right 3, 1, 2, 3. We need to go down 3, 1, 2, 3. And to the left 3, 1, 2, and 3. A little bit more ovally based on my board, but that's okay. But that's a nice picture of our circle. So there's the graph. So the only things we have left are our domain and our range. Remember, domain are our x values. So what are the x values that can lie on this circle? Well, the reason why I had you graph it first is because if we just look at what x values are included in our circle. Well, we go all the way from negative 1 all the way over to 1, 2, 3, 4, 5. Those are included because they lie on our circle. So we have our domain is negative 1 all the way up to 5. And we use brackets because it is included. Then we do a similar process for our range. I was like, why is it R? Because it's the range. So we go from negative 1 all the way down to 1, 2, 3, 4, 5, 6, 7. All the way down to negative 7. So our range is from negative 7 to negative 1. You could have figured out your domain and your range before graphing it by simply adding and subtracting your radius to your x values and your y value. Because if we add 3 to our x's, we're going to get up to 5. If we subtract 3 from our x's, we're going to get down to negative 1. If we add 3 to our y values, we go up to negative 1. If we subtract 3, we go down to negative 7. So you can find your domain and range by adding and subtracting your radius to your x's and your y's, or you can graph it and see how it falls on the graph. If you're a visual learner, this might work better. If you want to just do the adding, you can do it this way. Either way is going to give you the exact same answers. Okay. So what about general form? General form of an equation, we don't usually use a lot. We've had general form of lines and of polynomials. And so now, of course, we're going to have a general form of our circle. So the general form of a circle, we have the x squared plus the y squared plus dx plus ey plus f equals 0, where the d, e, and the f are just constants. So if they give you the equation of a circle in general form, they're usually going to ask you to get it back to standard form and then to graph it. So how do we do this? This is where I'm going to put a little star, and I want to remind you of something from 1.5. I know that's been a while ago, but in chapter 1, section 5, we did this neat thing called completing the square. And what that did was that helped us to get perfect squares when we were solving our equations and our quadratics. So you need to remember that in order to get your standard or your general form to standard form. So if you feel a little rusty, 1.5 is where we learned that. And you can go back and watch my lecture videos, or you can go back and do some of the homework again if you want some refresher just on completing the square. Okay, so here's our example. We have x squared plus y squared plus 4x minus 6y minus 23 equals 0. And we want to get that to standard form. So standard form, again, I'm going to write it, is x minus h squared plus y minus k squared equals r squared. That's our ultimate goal. We want to get to this, but we have all of this stuff to deal with first. So what do? Well, the first thing we do is we group up our x's and our y's, and we're going to get our constant over to the other side. I'm going to say this, and I'm going to give you a little heads up. Leave some spaces. I'm going to write in the spaces because that's how we're going to put in our completing the square stuff. Back when we were doing this with quadratics, we would leave a space as well. And this is the same thing we're doing. We're just going to do it twice. So I have x squared and then 4x. And then I'm going to put a plus and I'm going to put a space. Then plus y squared minus 6y plus and a space. And I'm adding my 23 over equals 23, not 24, 23. And then I'm going to put plus space plus space. There's a space here and a space here. Okay? Because whatever I do on the left-hand side, I have to do on my right-hand side to keep it balanced. So obviously you're not here because this is virtual. So I would ask you, who remembers how to complete the square? Hopefully somebody would say, oh, you do this, and that would be correct. So what we do is we look at our b. We take half of our b and we square it. And that is what we do. So half of our b is 2, and we square it, that becomes 4. So I write that in my blank. I also walk over here and I write it in the first blank on the right-hand side. Then I say, okay, what is half of my b here? Well, it's -3. And if I square that, I get a +9. And I add that over here. Whatever I do on this side, I have to do on this side. So the whole reason we do that is so that we have a perfect square like this. Remember, this spot we know is 1/2 of our b. So half of our b is 2, so that goes there. All of that quantity squared. Plus y, half of our b is a -3, minus 3 squared. Then I have 23 plus 4, which is 27, plus 9 equals 36. Here's another little thing. This will almost always, I mean, every time I've ever done it, and I don't try to trick you guys up and give you tricky problems, so that should be a perfect square. So now we have a circle that has a center of -2, 3 with a radius of 6. Half of b, square it, add it here and here. Half of b, square it, add it here and here. Then when you write them as perfect squares, this is just your half of b. Now I said I was going to graph it, but that's a really big graph. So I'm going to show you my graph, or you can pull up your notes. So again, I graphed the point -2, 3, right there. And then I counted to the right and to the left and up and down 6 points and plotted my other points and connected. And that's it.